Hi, I'm Andrea and welcome to Productive C Sharp. In this video, I want to talk you how you can return values from tasks, how to monitor the status of execution of your tasks, and for example, know if a task is completed. This is a requirement in order to prepare for a C Sharp specialist certification. So in previous videos, we've seen that we can use the thread pool QUserWork in order to run code asynchronously. One of the problems of using the thread pool is that it's not possible to start asynchronous code and that returns values. So you can only spin up a fire and forget code, and there is no way to know if the operation is completed and what's the actual return value of the operation. So that's why the tasks enable you to do this, and they are more powerful. A more powerful abstraction in order to do asynchronous operations. So I want to show you how you can actually start a task that returns a value and monitor the status. So here I have a program that creates two tasks, task 1 and task 2. As you can see, I'm using the class task that takes an argument that is the return type of the task. In this case, we are just returning an integer. Okay. Then I create two new tasks, and as you can see, the task at the moment is, the first task is simply waiting for 2 seconds and then returning a simple constant value. And then the other task is, waiting for 3 seconds and returning 20. Then I have a function that I called print task status that is simply printing the value of the property status of those two tasks. And this status properties is a way for us to know what's the current status of the task. And I'm going to show you in a second. This task could be in different status, like the task might not be run, or it could be running, or actually is completed. So I will show you in a second. Then the next step is actually starting those tasks. So I use the start method to start those two tasks, and then I print the status again because I want to show you the different status. Then I wait for 500 milliseconds. I print the status again. And then I call the wait method on task 1. The wait method is a blocking call. So that basically means that this program will stop execution at the point when we call the wait until the task 1 is completed. And as soon as it's complete, the program execution continues, and then I can use the result property in order to get the result from task 1, and then I print the result. And then I do the same for the task 2. I wait for the task 2 to complete, and then I print the result. Okay? And along the way, I print the status of those tasks so that we can understand better what's the life cycle of tasks in .NET. Let me run the program. Okay, so as you can see, when we start, the first line is saying that task 1 and task 2 are both in the created state. So this is basically the state when the task has been created, but is not yet ready to run. We haven't told the task to start. As soon as I call start, you can see that the status moved to from create to waiting to run. So the tasks now are scheduled to run, but they are not yet running because the processor is not yet ready to run them. As soon as I wait 500 milliseconds and then I print again the status, you can see that both the tasks now are in the running state. So this means that task 1 and task 2 are simultaneously executing their code. If you notice the execution of the program, then we printed waiting for result 1, and then the program stopped before showing the result 1. Stopped for about 1.5 seconds. That's basically the time in order for the task 1 to complete. Then we print the result 2, and this happens after a second since the end of task 1. And the reason is because task 2 actually execute at the same time. So you don't need to wait 3 seconds in order to get the result of task 2, because task 2 was actually running at the same time as task 1. And as you can see, the status at the end of the execution is run to completion, because both the tasks completed and they actually finished their job. So basically what we did is we created two tasks, we start them, we monitor the status using the status property, we called wait in order to wait for the completion of a task, and we call the result property in order to get the result back from the task. There's another important thing I want to mention, is that if we don't call the wait method in both cases, the program execution is exactly the same as before. This means that when you call result is going to block the current thread until the task 1 is completed and result is available. So the wait call is not strictly necessary because result is also a blocking call. So keep that in mind. I want to show you another property that is important, that is the task 1.isComplete. So the property is completed. It's a boolean that tells you if the task completed. There are three possible ways a task can complete. One is run to completion, what we've seen in this example. And there are other two states. One is faulted and one is cancelled. Faulted is when something bad happened inside a task, an exception is thrown, so something went wrong. So we're going to talk about this in another video. And another possible completion state is cancelled, when a task has been explicitly cancelled by the user or by the program. And also we're going to talk about this in a separate video. But the most important things to understand with the task parallel library, the task library, is basically that you can create asynchronous code, you can monitor the status of this code, and you can get results from this task, something that you were not able to do using the thread pool before in .NET, before the task library has been created. And so this is important to understand in order to pass the C# certification, because the tasks is a concept that you need to master in order to be able to pass the exam. So thank you very much for watching.